Okay, so there is a new concept in same uh,
Like, like in waves or
yes,
another topic?
wave.
Oh,
No, we are still talking about wave. So basically, we about reflection of wave.
I heard of it.
Yes, because we know that in secondary classes we talk about the reflection of light because light is also a type of wave, right?
Yeah.
So we also need to discuss about the basic property for the wave. So we need to discuss about the reflection in wave in general, right? We are not going to talk about a
Yes.
specific sound or light wave. We only talk about reflection of wave, right?
Mm-hmm.
So basically reflection occurs when about bounce back, reflecting.
Back from from a
Yes.
reflection.
Let's suppose you consider example of a ball. You try to hit a tennis ball on a ball, so that ball will bounce back in the opposite direction, right?
Yes.
So same goes to be happen with the waves. Let's suppose if water waves are traveling from one point to another, and you place a barrier in the path of water waves, so those water waves are going to strike that barrier and reflect back, right?
Right.
And the second important thing is that we know the basic postulates for the reflection. What are the basic postulates of reflection? You need to know about these two things. The first one is, let's suppose if there is a barrier, if we consider a wave, suppose these are waves.
Running sound.
So let's suppose these are waves moving in a straight line and there is a reflecting
Okay.
surface. Let's
Okay.
consider a reflecting surface over here. This is a reflecting surface. Let's suppose this is a, and these are waves.
Okay.
So when they strike or collide with this bar, so we can easily identify their direction. So this is the direction of, right? And it will reflect back in, right?
Wait, I want to draw the diagram.
Uh, no, you don't have to draw a diagram every time. In cases, if they ask to draw the half of the diagram, so then you need to draw the diagram. And how I know that waves will move in this direction? So that is the first postulate for the reflection of wave, that you need to remember that the angle of incidence for a wave always equal.
Okay. Angle. I've heard the angle of
Yes, I'm going to tell you that how to measure the angle from in the diagram. So the postulate is angle of incidence for a wave will always equal to an angle of reflection. There is a concept of angle, and I'm going to find angle. First of all, the most basic thing in measuring the angle, that first you need to consider a reflecting surface, right? This is our
yeah.
reflecting surface. And you need to place your ruler in such a way that is always perpendicular to the reflecting surface, right? Let's suppose this is the point, waves are to collide with the bar, right? So you need to
Right.
draw a perpendicular line with the surface like this, right?
Right.
Now we can easily measure the angle. How we are going to measure the angle? This is angle, right? Because waves are coming towards the barrier. So that is incident, angle of incidence.
Rope incidence is always equal to the angle of a
Yes.
reflection.
Yes. So if you measure it protector or the D or the compass, so that will give you the same, that is angle of reflection. So that I means incidence, and that R will give you the value angle of, so that is the concept of angle of incidence and angle of reflection. So that will always equal, right?
Yeah.
So to measure the angle, always remember that you need to draw a normal line. I'm writing this is our normal line. The dotted line is basically a normal, because we need to measure normal line. Never make measure angle with the surface, right? Always measure angle with normal line, right?
Oh,
I'm
right.
also writing it over here so that will easy to understand. Angle that also help in the first light chapter. We need to measure the angle. So always measure normal line, right? Any confusion?
No, no confusion so far.
Okay. Okay. And the second term is, this is our first term. First step or first related to the property of wave. And the second one, refraction. Refraction is something different from reflection, right?
Yeah, I've heard of the term.
Yes. Basically, this give you the of light in glass, in prism, or when light passes into the swimming pool or in the water. So there will be a change in the path of light. So that is refraction, bending of light, right?
Oh, okay, okay.
Yes. So that is the concept of refraction. So basically, in water, we are not going to refract in the same manner like light waves. So we need to do something different, right? Because water waves are already like a water surface or water waves. So we are not able to change their path in water wave, right? So we need to do something different, right? So we need to use two different mediums. Two different medium means, let's suppose if water waves are moving in deep and shallow water, right? Let's suppose if we consider the example of seaside, so water waves are generating from deep water, right? And when those waves are moving to the corner of that water surface, so that is the shallow medium, right? Like this, let's suppose if we talk about the bending of waves. So bending of wave means we need two type of medium. First one is a shallow medium. We need to know about shallow medium, and we need to know about a deep, right? Let's suppose if we consider a swimming pool, so let's suppose half of the pool is a deep one, so that is the deep medium because there are more water molecules. And let's suppose one side of the swimming pool is the shallow one, so there are less number of water molecules, right? So there is a change in medium. Pool is not a uniform or not balanced, so there are different medium and different depth of the water, right? So what happens, let's suppose you need to know about three important terms over here. The first one is you need to know about the frequency in deep water and shallow water. Second one is speed in shallow and deep water, right? And the third one is the length. Need about these know about these three terms in deep and shallow water. So first of all, let's talk about shallow water. shallow medium. So if about shallow medium, so basically shallow medium is less deep or less in depth. So in that section,
Shallow medium has like less depth than like
yes,
the deep medium.
yes. So wavelength will be
Oh,
shorter in shallow medium, right? And if we
yeah.
talk about this, so speed will also be slow in water, right? And frequency remains same like water, right? And finally, if we talk about medium, because it is greater in depth as compared to the shallow medium, so in that section, wavelength will be greater and speed will also be greater or speed will be far compared to shallow medium. And the final thing is frequency. Frequency remains same in both cases, right?
Right. I'm writing it down.
These three terms are very important because many questions are related to that concept only. I will also send the PDF of this file to you after the class, because if you take a look over the questions, so many questions are related. So let me show you, like this one. Let's suppose if we only consider this question number 38. So the diagram shows a wave moving into a shallow water, right? Now you consider this is the depth of the water at initial stage, and this is the depth of final stage. And you compare the depth of water that after moving some time, the depth of the water will decrease.
It's like, does the speed is the speed faster for a deep like medium,
Yes.
or is it the same?
Yes. Speed will be faster in deep medium.
Um,
So in this question, we know that frequency remains same. So only speed decrease, right? Because we know frequency remains same.
yeah, the
So these
because it's
types of, yes. So these type of questions are very much included in your exam. We will also discuss in classes, because today we will only discuss related to the basic terms, right?